Thank you so much to everybody for joining our inaugural Creek courses. Today we're going to be talking all about the Chesapeake Bay and providing an introduction to water quality and policy. My name is Helen Schlimm and I am ALLARM's Community Science Specialist, and I'll be co-hosting today with our Outreach and Communication Specialist, Hayat Rasul, and our Assistant Director, Suzanne Hartley, is also on board to help us answer some questions at the end. So thanks very much for taking the next hour out of your day to join us and learn about some fun topics. This is a new series that we're launching, Creek Courses, in order to stay connected with folks and our awesome partners and volunteers while we're not as able to go out and to our streams and do monitoring during this time. So I'm going to get us started here. Just as a reminder to who we are, the Alliance for Aquatic Resource Monitoring. We are a community science organization based at Dickinson College here in Carlisle, Pennsylvania. And we do employ between 10 and 12 undergraduate students as watershed coordinators. Many of you will have met our awesome students at trainings and follow-up meetings and fun things like that. We are about 40% supported by Dickinson College and about 60% supported by external grants. So I mentioned a little bit that this is our inaugural Creek course session, and our purpose with these courses is to explore fun water quality topics relevant to stream monitoring activities, and learn some more about our region and the important things going on in our waterways. So today is our first class, as I said, an introduction to water quality and policy of the Chesapeake Bay. Our next class will be May 21st, where we're going to continue this presentation and dive deeper into more recent policy and some cleanup efforts and the role of monitoring. You can see some other topics for our courses as we continue into June and the summer. And if you have topics that you're particularly interested around water quality or environment, please feel free to put those in the chat and we welcome all of your feedback. So just some housekeeping. Oh, don't want to skip this slide. Thanks to everyone who enables us to do the work that we love to do. All of these awesome organizations and our funders, as well as our watershed organization friends and many more that aren't listed on this slide. So just some housekeeping for this Zoom call. Everybody has been automatically muted, and feel free to have your camera on or off, whatever you're comfortable with. Please hold and type your questions into the chat function. We will have time to address questions at the end. And then if you can briefly introduce yourself in the chat with your name, who's your affiliation with, and what water body you monitor or you're particularly fond of, that's a great way for us to see who all is going to be joining us today. So with that, I'm going to keep admitting people as they join, and we're going to turn it over to Hayat to get us started and introduce us to all things Chesapeake Bay.
Yeah, thank you, Helen. Again, my name is Hayat Rasul, and I'm ALLARM's Outreach and Communication Specialist. I'm super excited to be presenting on this topic today. So we'll start with an overview of the entire Chesapeake Bay watershed. This image is an outline of the entire region. And for review for some, a watershed is a regional drainage basin that revolves around a lowest point of elevation. And that can vary in scale and size. So this image shows the sub-watersheds for the major river basins throughout the entire Chesapeake Bay. And as you can see, that light green color that is over Pennsylvania and New York represents the Susquehanna River Basin. So these are the different sub-river basins within the entire larger Chesapeake Bay watershed. This image is zoomed into Pennsylvania, specifically with the Susquehanna River Basin. So you see the west branch of the river flowing into the east branch, combining into the larger Susquehanna River. And this eventually deposits into the Chesapeake Bay. And I like this image because it shows how much of the Chesapeake Bay watershed and how much of a role we really have in terms of that water quality that ends up in the Chesapeake Bay. So here are a couple of fun bay facts. The bay crosses 6 different states in addition to DC. And so this area is over 64,000 square miles, which is a lot of space. And In total, including rivers and streams, there are about 11,000 miles of shoreline in the entire watershed, with an average depth of 20 feet, with a maximum depth of 175 feet in the bay proper. And the Chesapeake Bay watershed houses 18.7 million people roughly, so that includes you. This is a very large estuary. It's the largest one in the United States, with 2 ocean outlets, one being man-made in the Chesapeake and Delaware canals, and then one being the natural opening into the ocean in the Virginia Capes. And in Maryland alone, the Chesapeake Bay ports provide 1 in 10 jobs, whether that is directly at ports or indirectly supporting those people. And again, Pennsylvania comprises 35% of the entire watershed. So we are important. Next slide, please. So prior to getting into things, it's extremely important to recognize the people who lived in the Chesapeake Bay prior to us existing. And these were among the first people who encountered European settlers, so there aren't a lot of written records. However, these indigenous people were dated by a Clovis point tool that was discovered at an archaeological site, which dated geochemically back to 9,000 years ago. And that tool was used to feed on very large animals like mammoths and mastodons. And then these people experienced a climate change that is natural in Earth's cycles, but also came about due to the introduction of agriculture and domestication. And so eventually those modern indigenous nations include the Powhatan, the Piscataway, and the Nanticoke, which are names that you might be familiar with. They might be street names, they might be stream names near you. So really ponder upon those names and think about where they came from. And now each United States state is responsible for recognizing those nations and have different regulations depending on the state and region. So sort of thinking about the ecology and going into the ecology of the bay now, we'll start with the importance of forests and that forests have in the Chesapeake Bay watershed and in watersheds in general. In the Chesapeake Bay region, there are over 2,700 different types of plants. So that ranges from very large trees to shrubs to submerged aquatic vegetation that is found in the various streams and rivers that flow throughout the Chesapeake Bay watershed and in the bay proper. And between 1982 and 1997, over 750,000 acres of forest in the bay watershed was lost to development. So that is at a rate of about 100 acres a day. And that is an unsustainable rate of deforestation. And so despite that level fluctuating over time, a lot of it now is responsible or is due to the concept of parcelization, which is basically the breakup of large land ownerships to smaller, more private ones. So if you think about like family-owned forests, this really complicates the land use designations of these forests. And so the loss of forest is really critical because forests provide, again, flood control. They filter water through the different chemical processes of plants and ecosystems throughout forests. They sequester carbon from our atmosphere. They provide habitat for a variety of different species. And they are really a great place to recreate. And we have a lot of intrinsic value as humans for forests. We'll try to go underground now and think about the geology of the Chesapeake Bay. It's really important to think about what we are standing on because those different geologic contacts influence the water quality. So I would encourage you to go through this slide, and the bay it took 36 million years in the making and only assumed its present shape 3,000 years ago. And each of these different geologic provinces have their own unique chemical makeup, and those hydrogeochemical variations impact water quality naturally. So for instance, in the Appalachian province in Pennsylvania, we're largely dominated by limestone and dolomite, which are two different types of rock types that are rich in calcium and magnesium, which really influences what we know as hard water. So there are different variations like that, and I encourage you to look into these different provinces. So going back above ground, we're transitioning into wetlands and estuaries. And wetlands are important for a variety of reasons. One, the mere acreage of wetlands in the Bay watershed. There are about 500,000 acres of wetlands. So that in itself provides a lot of habitat for different species, whether they are permanent in the region or they're migratory. So if we think about the millions of different migratory waterfowl that use the bay as a pit stop in their journey. These are very highly productive environments because of the different species that exist there, both permanently and temporarily. And they also provide a very important value for humans because they act as flood control regions due to the different root structures of submerged aquatic vegetation. And they also provide a point of filtration before water reaches the ocean and the estuaries. So it plays a really pivotal role in the water cycle in general. Wetlands are really sensitive to changes in sea level rise and salinity. So the Bay is really trying to monitor how those wetlands are changing over time and what we can do to mitigate their disappearance. After water flows through wetlands, they end up in the estuary. So estuaries are a mixture of fresh water and salt water, and so are wetlands. And so that chemical variation in the amount of salt that spans over an estuary allows for different species that need different levels of salinity to survive. So that chemical habitat range is really it's pushing that biodiversity chemically, in addition to that physical biodiversity of having a variety of different habitat ranges from shallow and open waters to wetlands to muddy areas to sandy areas and oyster reefs. So both of those things really encourage a variety of different species to live in the Bay. And because of that biodiversity, there is a large economic value that's associated with that. Different species like these oysters, in this mini clip here of Helen, if you want to play that, shows how their role as oysters to filter water is extremely beneficial to Bay water quality. And so with the disappearance of species like this, that really impacts Bay quality. And so I like this clip because it quite literally shows the clearing of that water over time. And beyond all of the environmental value and economic value of estuaries, they're beautiful and have a very intrinsic value for us as humans as well. So this is a snapshot of the different types of species that live in the Bay. The Bay program has a field guide on their website. So this is simply a snapshot of the different species. You can find so many different beautiful pictures on that website. And we, of course, didn't forget to include our beloved muskrat in the bottom corner. And if we think about this overall, each of those natural sub-ecosystems and portions of the watershed provide over $107 billion a year and provide that to the Chesapeake Bay watershed's economy. A portion of that economy, over $2 billion in sales associated with the seafood industry, shows how much of an importance the seafood industry has in that role. And that in itself provides over 40,000 jobs. And thinking back to those oysters, a decline in their populations really impacted the economy in Maryland and Virginia by over $4 billion. So that's really detrimental, and thinking about these things is important. The Pennsylvania fishing industry in itself contributes $1.6 billion a year to the entire Bay watershed's economy. So that's a fun fact. And again, both having different commodities coming from the Bay, in addition to having recreational activities, that really provide steady jobs for so many people in the entire Bay watershed. So with that overview, I'm going to pass it on to Helen to see how those things intertwine with each other. So Helen, take it away.
Yeah, thanks, Hayat. So we've learned about the really fun and unique benefits and characteristics of the Bay and its really, really large watershed. Unfortunately, as we all know, we're from this region, and there are some pretty strong issues that we are facing within water quality and the health of the bay. Pretty nicely exemplified, I think, by this picture of a cow wading into a eutrophied waterway. So I'm going to dive into some of our big picture pollution concerns, starting with how we have changed our natural landscape over the past few centuries and escalated those changes over the past few decades. And so the population, as Hayat said, of the whole watershed region this year is 18.7 million people. And as you can see from this diagram here, that number is expected to project into 21.1 million people in just the next few decades. So it's very significant as we're continuing to increase the population. Obviously, we have lots of major cities, and all of these people need to live somewhere, work somewhere, and eat something. So changing our natural landscapes from vegetated areas into some more paved surfaces has had some significant and long-lasting effects on our bay water quality health. So before we dive more specifically into some of those water quality challenges, it's worth mentioning how air pollution is also a challenge for the bay and for human health, of course. So we know the watershed area is 64,000 square miles. The airshed of the Chesapeake Bay region is actually 9 times that size. So we're looking at a very significant portion of the United States where that air will travel over the bay. And many of the pollutants that are absorbed in the air do get absorbed by the bay waters and have negative impacts on human health as well as water quality and the impacts on species and other things that live in the bay. Of most notable concern when we're talking about air pollution is that a little less than 1/3 of nitrogen sources in the bay actually comes from degassing from the atmosphere. So these are things like nitrous oxides that are produced through the burning of fossil fuels, either from transportation and energy. Also, ammonia emissions are a big concern from farming operations and things like that. And they do make their way into the waterways as well. Additional concerns when we're talking about air pollution include various chemical contaminants, toxic metals, plastics, other things that make their way into our air and also into our water. And before I move on, it's always worth pointing out the difference between point source and non-point source pollution. So in that top arrow, right, we're pointing at the smokestack. So that's an example of point source pollution. We know that factory, that company, we can regulate more easily that particular pipe versus non-point source pollution, which is our greatest challenge, where there's all sorts of diffuse sources coming in, and it's very hard or even impossible to look at the original source of those pollutants. So when we get into our non-point source pollution more specifically, the first one that sort of comes to mind when we're talking about development and where we all live is, of course, runoff or stormwater. So when it rains or snows on our landscape and all that water melts, it has to run off somewhere. And unfortunately, that's our local streams and waterways. And in our region, it all makes its way to the bay. So this is a really key non-point source pollution. And these waters can flow treated or untreated into local waterways, depending on where you live, what sort of stormwater regulation exists where you live, whether you have an MS4 permit and things like that. So runoff continues to be an increasing concern and has been for many decades. And additionally, it poses a health hazard through flooding, as we are removing sort of these natural filtration areas and putting more impervious surfaces on our ground. We are trapping our water. In addition, and I'm not going to get too much into how climate change is projected to affect this region, but generally speaking, we are predicted to get more rainfall over the coming years, as well as an increased temperature. And so all of these things, unfortunately, will continue to have detrimental effects on our waterways and on the bay. And I think we can all remember just 2 years ago in 2018, where we had significantly high amounts of rainfall. That is projected to continue to happen through our region. So now we're going to get into the big 3 pollutants for the Chesapeake Bay, which are sediment nutrients, or nitrogen and phosphorus. And I'm going to let this nice video from the Chesapeake Bay program explain at a glance what some of the issues with sediment are.
Sediment is a major pollutant in Chesapeake Bay, its watershed, and its smaller creeks. It has a problem in the bay of reducing light, which is affecting submerged aquatic vegetation. And in these smaller creeks, that's affecting the habitat health. So we have a big question, which is, where is this sediment coming from? If we found out that it was coming from farms, we would engage NRCS to work with the farmers and go ahead and do conservation practices. If it turns out that the banks are the major source of sediment, we might want to start looking at stream restoration. So understanding where the sediment comes from has very important management implications.
So yes, important sources of sediment is coming off of our lands from construction sites, farm fields, but also just stream banks being eroded, shorelines being eroded. And really important to note about the sediment is not just the physical properties of the sediment that is causing an issue by, blocking the light in the bay, and that's negatively affecting the ability of plants to photosynthesize. It also smothers habitats. It's also filling in channels, which presents different and complex challenges for different industries and things like that. But what's important about sediment as well is that phosphorus, the nutrient, binds to sediment in a way that nitrogen does not. So it's sort of a double whammy when you have a lot of sediment being flushed down into the bay, which we can see does occur. This is a sort of infamous photo satellite image taken of the Chesapeake Bay from 2011 when Tropical Storm Lee came through the region. You can very, very clearly see that plume of sediment being flushed down from the upper part of the bay. And that takes us into an interesting case study, which is the Conowingo Dam. And many of us on this call are probably familiar with the Conowingo Dam and the unique challenges that it presents. But it is a hydroelectric generating facility at the base of the Susquehanna River. So we've learned how important the Susquehanna River is for the bay, how it provides nearly half of the bay's fresh water and drains all of that land in the upper part of the watershed. So this dam has been in place since 1928. And for many, many decades, it was an interesting trapping mechanism for that pollution entering the bay. So it actually had almost a positive effect for several years there, from the dam and the reservoir filling up with the sediment and filling up with the nutrients that have been binded to the sediment, as well as other types of pollutants and trash and things like that. But for many decades now, since it has been in operation for a long time, that effectiveness, trapping capacity has been reached. So in 2011, we saw with that picture, much of the sediment and nutrients was scoured over the dam and flushed in pulses down to the Chesapeake Bay. So that continues to be why it's now a more contentious issue in terms of water quality, because its function as a pollution gate is quickly coming to an end and hasn't even ended. So as we're continuing to look at how climate change is going to affect this region, if we get more years like 2018, that was a year where we saw a lot of things being flushed down into the upper bay over the reservoir and things like that. So what's interesting, the company that operates this dam is Exelon Energy. They reached the end of their previous operating license with the Federal Energy Regulation Commission in 2014. And since that year, they have been working to get a next operating license in place. And there's been several studies done, and they settled with the state of Maryland last year to have a water quality permit. And in the next 50 years, what happened is that Exelon has agreed to commit $200 million to looking at different water quality studies, examining how the sediment could be repurposed potentially, and looking at some important ecological studies as well, like repopulating mussel populations and providing better passages for eels and other important things that dams sort of block when they're sitting on the edge of the river. So I could go a lot more into detail about the Conowingo Dam. I'm sure many of us are also very familiar with this case study, but it's a really interesting one in terms of sediment as well as nutrients, which we're going to just hear a little bit more about now with turning it back to Hayat and getting us further into the picture of water quality in the bay.
So we appreciate the role that agriculture plays in our daily lives. Agriculture provides us with food as well as intrinsic value and environmental benefits as well. But when things are done in excess, we do know that that can be impactful. According to the USDA, there are over 83,000 different farm operations in the Chesapeake Bay watershed, with 50 different consumer commodities being produced. So that is a high demand. And when thinking in such large numbers with such a high demand, although conventional tillage and pest remediation and irrigation can be beneficial, their excessive use can really push those sediments and pollutants like nutrients into our waterways. This image is interesting to examine. It's the total nitrogen associated with manure in the Chesapeake Bay watershed's counties. And you could see the really high stacks in red associated with areas that are dense in farm and agricultural production. So in the Shenandoah Valley, Lancaster County, and the Delmarva Peninsula, you could see those stacks are really, really high. Next slide, please. So we recall that Pennsylvania is 35% of the Bay watershed in land area, with over 83,000 operations in the Chesapeake Bay. And there's a really interesting statistic that there are 11-to-1 ratio of livestock to humans in the Chesapeake Bay watershed. So with those statistics in mind, the Susquehanna River pushes 42% of nitrogen in the bay, 55% of phosphorus, and 60% of sediments. And in this diagram, you can see that those nutrients that are carried with runoff, that nitrogen and phosphorus, just like you fertilize your gardens and farming operations use fertilizers to help their crops grow, that also encourages growth of microscopic plants and animals in streams and freshwater bodies and in the Chesapeake Bay. So that really encourages that growth, which limits sunlight and thus slows the photosynthetic properties of plants, which limits oxygen and eventually really harms wildlife. So that nutrient runoff can end up in fish kills and dead zones because of that chemical process that happens with algae blooms. So this image is very busy, but I encourage you to look into it in detail. It really shows the different chemical processes that are very complicated that contribute to eutrophication, the concept of algae blooms from nutrient runoff. And so I encourage you to look at the different processes in this that come from both point source and non-point source pollution that Helen mentioned earlier, and follow those arrows and see how those different processes really impact water quality.
So we're gonna come into the final part of our presentation here, which is, the question that I think we get very often, which is, how is the bay doing? Or, how healthy is the bay? And it's a complicated question with a complicated answer. And there's many groups and organizations who classified different grades to the bay or to different parts of the bay. And that will lead us into looking at how we have responded policy-wise throughout the whole watershed and take us into the final part of our presentation. So to start with, we like to show this map when we talk about the Chesapeake Bay. It is a little bit old at this point, but it does still show some really important points about the water quality health of the whole watershed. So chances are that everybody on this call lives in an area that ranges between fair and very poor. You can see here those excellent or good ratings are pretty few and far in between. What this map does show is a biotic integrity rating. So what it is doing is measuring water quality based on macroinvertebrate sampling. It has some of its own unique characteristics and things like that. But we like to show this map as a baseline, so we know what we're dealing with when we're looking throughout the whole watershed. Another way that the Bay health sort of gets characterized is through some key report cards and publications, notably the Chesapeake Bay Foundation, which is one of the key Chesapeake advocacy and education organizations. They put out a biannual report card called the State of the Bay. And as we can see, their most recent one was in 2018, and that gave the Bay a D+, which actually was a slight decline from the 2016 report card. And they break out those scores through different categories, including pollution, habitat, and fisheries. And we can see sort of the grades on our report card here. Most of them reflect, unfortunately, not very good scores, although there have been some fun and exciting successes in recent years with some recovery, for example, of underwater grasses and the blue crab population doing pretty well, all things considered. Unfortunately, some of our really important characteristic species like oysters and rockfish really hit a decline a couple centuries ago, and we've been working hard to try to recover some of those really important species, but that's a major challenge due to our overharvesting in past centuries, as well as some other pollution concerns and some viruses, specifically when we're talking about oysters. So there is some good news though. When we look at the Bay Foundation's report card, which they've done for a few decades now, we do see an increasing trend, which is exciting. However, you can see that we are pretty far from saved or even stable at this point. So hoping to continue that trend and see some real achievable improvements. Another key academic institution is the University of Maryland Center for Environmental Science. They put out a lot of report cards as well. This is from their 2018 report looking at the Bay itself, and it gave it a grade of C or moderate, and you can see how that's broken down into the various categories as well. So what we're looking at generally is that the Bay is unfortunately not doing very well. So how have we responded to this? I'm going to take a step back a little bit historically and in context. So in the 1960s and 70s, sort of across the whole country, the nation was waking up to the fact that our waters were in pretty poor condition. You know, you had the Cuyahoga River in Ohio, which was literally able to catch fire several times throughout its history. And the EPA started looking more specifically at water quality regulations and water quality pollution as a real concern. And you can see this picture from the 70s of the Bay. You know, accounts from that time talk about how the Bay was very noticeably dirty. It had lots of bad odors. There were noticeable fish kills and things like that coming from pretty much unchecked regulations and pollution sources throughout the watershed. So in response to this, some really key organizations were founded around these decades. I'm including the Chesapeake Bay Foundation, which I've already talked about, the Susquehanna River Basin Commission, the Alliance for the Chesapeake Bay, all really important organizations that still exist and do awesome work today. And notably, the EPA created the Chesapeake Bay Program in 1983, which is a quasi-governmental partnership still located in Annapolis, Maryland. And I'm going to get a little bit into more of those details in a second, but we cannot talk about water quality regulation without talking about the Clean Water Act. So this is a groundbreaking piece of environmental legislation signed in 1972 by Richard Nixon. It actually expanded on the 1948 Federal Water Pollution Control Act. But again, there was lots of pressures in this time period for environmental issues to start being addressed. So we still consider this a really important and groundbreaking piece of legislation when we're talking about water quality. So some really important things that the Clean Water Act did was set federal mandates that states needed to start setting standards and requirements for water health and water quality, and then they would have to maintain and meet those standards. It also established the National Pollutant Discharge Elimination System, or NPDES. So this was really targeting those point sources of pollution, and for the first time, you know, you had to have a permit if you had a pipe or a drain that was pushing effluent out into our common waterways and natural resources. So this was really, really important and took important stabs at those types of pollutants, including our wastewater treatment sector. There were lots of improvements made under this act, and also some important protections of our wetlands and other natural areas, which we know have a lot of value. There were also, of course, some challenges with the Clean Water Act, which still exists today, even in its more recent amendments. Slow compliance with some of the permits and exemptions that took place. But for the most notable one, and this is a theme that we're going to see as we continue our policy journey, is the challenge of these non-point sources of pollution, and how do you regulate when you don't exactly know where it originated. So we're going to see that continue as we come back more specifically to the Bay. So as I just mentioned a few minutes ago, the Chesapeake Bay program was formed in 1983. And this was resulting of a congressionally mandated study that was essentially said, the Bay is really dirty, we need to start cleaning it up. So it brought together the states of Maryland, Virginia, and Pennsylvania, as well as a representative from DC and the EPA. And they came together and established this Chesapeake Bay office in Annapolis. They created the Chesapeake Executive Council and some really other important collaborative working groups and things like that. And they signed a pledge that was the first original agreement, a voluntary pledge saying we need to start cleaning up the Bay. Unfortunately, this was had a few shortcomings, the original iteration, including that it lacked some key details around regulation, enforcement, and a deadline. Also notably, it was not in agreement with all the states, all of the watershed states yet, so we'll see how that continued to unfold. So it was great to start with that, but they quickly realized that they needed to amend the watershed agreement, and that took place in 1987 for the first time. And for this time, we finally see some numeric goals being set. So we know that these nutrients are the real concern, nutrients and sediments. So we want to reduce nitrogen and phosphorus by 40% by the year 2000. I'd also introduced some other important strategies around improving other areas of water quality and bay health, and included some important social aspects as well, like promoting environmental education and stewardship and access for people to recreationally enjoy the Bay. However, our theme continues here with not the question of addressing non-point sources of pollution being very challenging. Also, there was no enforcement. This is a voluntary agreement for those states who had signed on to this policy. So in addition to these sort of jurisdiction-wide policies that were taking place in the 80s and 90s, states like Maryland and Virginia, whose front door is the Chesapeake Bay, were passing some local initiatives, wanting to see some, in their tidal zones of the states, wanting to see some more rapid improvements in bay quality and in water quality. In Pennsylvania in the 90s, we started to pass some nutrient management laws, recognizing the impacts of agriculture and runoff of sediments and other negative detrimental things to our waterways. So that leads us to the Chesapeake 2000 agreement, which was the next iteration of the Chesapeake agreement, still a voluntary agreement, but was notable about this agreement was that all of the headwaters states joined in the efforts. So we had New York, Delaware, and West Virginia at the table at this point. This was a really ambitious agreement. It set 102 goals to reduce pollution and protect other really important parts of bay health and conservation measures. Unfortunately, the shortcomings that lied with this agreement is, again, they set that the restoration would be in place by 2010. And as we now know, that was truly an unrealistic deadline. And there were also still those key figures of enforcement being lacking. And still the challenge of how do we address 64,000 square miles of diffuse pollution sources. So that will lead us into our next course on May 21st, where we're going to hit the ground running with the total maximum daily load and the executive order of 2009, and how that has led us into our most recent policy responses and how we're seeing some achievable actions throughout the Bay. And we'll dive a little bit into Pennsylvania, more specifically how it's achieving some of those actions and the role of monitoring and restoration. So with that, I'm going to end our presentation for today. You can see here a flyer for our creek courses continuing in June. We're going to have 2 topics about stream health influencers and water policy. So if you're interested in continuing to join our courses, you can register here or email us and let us know. But thank you very much for joining our inaugural creek course. I hope you learned something about the bay, and we're going to have some time now for questions.